All right, welcome back. This is at THS Mr. Jones, and we're going to talk about chapter 5.3, which is properties of logarithms. Um, so you had many properties of exponents, which such properties as like bm times bn equaled b to the m plus n. Okay, now remember that exponents and logarithms are very much related. So let's just start a list of some properties. Okay, so the first one we're going to look at is log base b of 1 equals 0. And what this is telling us is that if I rewrite this, this says that b to the 0 equals 1. And that is a property of exponents that we all should be fairly well aware of. Okay, we have log base b, and this just represents any base that I pick. So log base b of b equals 1. And I'll come back and do the exponents a little bit later. So this is chapter 5.3, properties. Properties. Oop, let me get my pen back. Of exponents, or of logs. Sorry, trying something new here just a little bit. Hopefully it'll be a little more, a little bit nicer on the eyes and the ears. Leave a comment if you're not liking it or if you are. So we also have log base b of b to the x equals x. We've got b to the log, so this is a power right here, of b to the x. So very similar to the last one, and we still get x with that. Okay, what you're seeing here is that my base of my logarithm and my base of my exponent are canceling each other out. Remember, we said exponential and logarithmic are inverses of each other, so they go away. And the same thing down here. I've got my base of my exponent and my base of my logarithm undo each other, so I'm left with x there. Some of the more difficult ones, but the ones that you need to know. So I have log base b of mn equals log of bm plus log b of n. So that's very similar to the multiplication we had with exponentials up there. And we have log base b of m over n, which would be log base b of m minus log base b of n. Okay, so just like subtraction with exponents, we have subtraction with logarithms. And make sure that we put the top one first and then subtract the bottom one, because that will make a difference. And then the last one we're going to look at is log b, so any base, m to the p power. That is p to the log base b of m. Okay, so if we go back here just a little bit, we can rewrite this one. This would be b to the first equals b, and we know that anything to the first power is itself. This one's a little bit more tricky to do, but let's just go back to what we were talking about earlier, and that is that the base of the exponent and the base of the logarithms are canceling each other out, leaving us with x. Same thing with those. These go back to like this one up here, where you have multiplication, we've got multiplication, same base, so we're going to split them up and add them back to each other. Okay, so we use these properties of logarithms to help expand and to help write as one. So I could have something like really long. So let's say I have 2 log 3 plus 4 log u. And this is an expanded form, meaning that there are many logarithms, or I'm writing it out as long as possible. So my goal in this one would be to write as one logarithm. Okay, so I'd only have one left. And how I would do that is I would use these properties here that we had just talked about, such as this one right here. If I have a coefficient out in front of my logarithm, I can bring it up to a power. So that's what I'm going to do here with this one. So I have log 3 squared would be that one, plus this 4 would also go up there. So we'll have log u to the 4th. Okay, so I can simplify with this. So I have log of 9 plus log, and since I can't actually work that out, we'll leave it u to the 4th. And if we look back and see, what do I do with 2 addition logs is I multiply them together. So here we'll write log of 9u to the 4th. And we would need to put that in parentheses, because if we don't, this u doesn't get the logarithm. Okay, so those are the kind of things that you'll be looking at. And we can go the other way around. Let's say we have ln of x to the 3rd over y squared. And the directions on this one would be to expand. So I'm trying to take this into this expanded form right here. Okay, so what do I do with division is what we're going to look at, which would be subtraction. And then so we'll have ln x to the 3rd minus ln of y squared. And then I can't leave this power, but if we remember, like right here, to get rid of that power, we bring it down in front. So this would be 3 ln x minus 2 ln y. But be careful, because if, let's say this was an e. Let's say this was e, and this was e. So then I have an e here. Well, what happens with ln and e is they cancel each other out. So then I'll just be left with 2 in that spot. Okay. Now, we talked about the other day that we can't use certain logs on our calculator. For example, we can't put in log base 2 of 3 in our calculator. So what we have is what's called the change of base formula. Okay, and what that does is that takes this and it changes the base into whatever I want. So we'll say log of base b of m. So whatever this is, that's our starting. We'll say log of m over log of b. Now, that's a b, that's not a base b, it's this base. Now, this one has a base 10, which is on the calculator. I could also say ln of m over ln of b. So I could take this problem right here, and I could say log of 3 over log of 2, and I could put that into the calculator and get out an answer, a solution. Okay, and again, we do that on our calculator here. If I show you here. If we come over here to the calculator, hopefully I can get it without a glare. Okay, so if we go back to the ln sub ln base 2 of log base 2 of 3, we'll say we'll simply say log of 3 over log of 2. And I'll put it like that. Or we could say ln of 3 divided by ln of 2. And we'd get that same answer no matter what I do. Now, there are some calculators. I don't know if this one will do it for me. But if you hit math, you can go down. Yeah, this one doesn't have it. But you could go down into that menu and pick any base that you want. So now we'll be able to graph any exponential that we want. So we'll stop right there for 5.3. Just really get down those properties, and we'll do a bunch of examples of expanding and reducing all those logarithms. So here are your questions for 5.3. So it looks like, what does it mean to expand? What is the change of base formula, and why is it important to have? And go ahead and list 4 properties of logarithms that we talked about. Here are your 5.3 suggested problems. So go ahead and write those down. We've got 59 will be our challenge problem. Again, this is your stopping point if you're going to be in class. If not, or if you just want to, you can go ahead and continue watching. We'll continue to go over some more specific examples of logarithms. Okay, let's get back to some examples. So we'll just start with some simple property examples. So here we've got, since my base and my of part of my logarithm match, we can also rewrite this. We can say 10 to what power is 10, and that would be 1. So this would be 1. We have kind of the same thing with ln e to the x plus 3. Since my logarithm and my base of my exponent cancel, that would be simply x plus 3. Now's where it gets into kind of the more complicated expanding problems. So let's look at log of 3 u squared square root of v. Okay, and we're going to expand on this. So we're going to split it all up. So notice here I have multiplication. So in order to split up multiplication, we're going to take it and we're going to do addition. It's kind of like if I were to just distribute this logarithm into each one, but instead I've got to put this addition in there. Okay, so if I've got a base, a different base and an exponent, I can bring this exponent out in front. So we'll say 2 log base 3 of u plus, now this square root is actually a power. This is, instead of writing square root of v, I should be writing v to the half power, and my half will come out front. So I have half log base 3 of v. And then we're completely expanded right there. So let's try another one real quick. Let's say ln of x. I think I just did that one a little bit ago. So let's go the other way. Let's say I have 2/3 ln x minus 1/2 ln of y. So these coefficients have to go away. So we're going to write as one logarithm. So these coefficients have to go in as exponents. So I'll have ln x to the 2/3 minus ln of y to the half. Okay, so I have subtraction here. Subtraction tells me division with this one on top. So I have ln of x to the 2/3 over y to the half. And there I have written it as one. See, I have one logarithm. Now you could write it like this. Let's say ln, and I would have the square root of y. And then remember, this one goes inside out. So this would be the third root of x squared. You could write it like that. Just kind of see what the directions tell you to do. Okay, let's try something a little bit longer here. So let's look at 3 log 3 of x plus log. Let's change this to a 4. Log 4 of 2x plus 1 minus 2 log 4 of 4. Okay, so we want to get rid of coefficients first. So I'll take the 3 and the 2 to the top. So I'll have log base 4 of x to the third plus, I don't have anything there to bring up. And then, so minus log base 4 of 4 squared. Okay, so right here we kind of notice that my log base and my base of my exponent here cancel each other out. So here we'll just get 2. So we'll say, well, let's leave it because we'll combine them. So in this case, we're going to do our addition first. Remember, order of operations, we go left or right. So addition says multiplication. So we'll say log base 4 of x to the third times 2x plus 1 minus log base 4 squared. Okay, so let's go ahead and distribute that. So we have log base 4 of 2x to the fourth plus x to the third minus log base 4 squared. 4 squared is 16, so we'll go ahead and write that. Okay, so I have same base, subtraction, that would mean division. So we have log base 4 of 2x to the fourth plus x to the third over 16. If I changed this to a 2 earlier, I wouldn't be able to combine the two because this has log base 4 and this one would not. So that's kind of why I left it. So we can do a lot of expanding and contracting with those. Again, we have the change of base formula, which is log of any base of m equals the log of m over the log of b. Okay, and this will help me change, let's say I have log base 3 of 8. That would now become log of 8 over log of 3. And I would be able to put that into my calculator. So if we say log of 4 to the 17, I could change that and say log of 17 over log of 4. Or I could even say ln of 17 over ln of 4. And I could put those into the calculator and we could get an approximate answer. So I'd say log of 17 divided by log of 4, and that would give me about 2.04. Okay, and this one up here, log of 8 over log of 3, that would give me about 1.89. So again, these are not actual like exact answers, but they're an estimation, a pretty close guess. So let me put back up here your suggested problems. So there's your suggested problems. Number 59 is your challenge problem. Go ahead and come to class with questions or come in and see me if you need extra help, and be ready for the quiz. As always, this is at THS Mr. Jones signing off. Thanks for watching. Subscribe, like. See you later.